All right, let's have a look at the solutions to assignment 63. Okay, question 1, simplify this expression. So when you want to simplify a complex number or an expression that involves a complex number, usually you need to simplify to the simplest form, which is a plus bi, right? So this is our target. Okay, so let's have a look at what can we do about it. So the original expression I minus I to the power of -1, then to the power of -1 is actually 1 over I minus 1 over I, right? And first of all, we can multiply an I to both the numerator and denominator, which will give us I squared minus 1. And then I over I squared is -1 and then -1. So this is actually I over -2, right? And the final result is -1/2 times I. This is already in the form A plus BI. So this is the final solution, okay? Be careful with this. Okay, any questions? Okay, by the way, I have returned the marked paper to your email. I don't know if you have received that. Did you see that? Okay. Okay, next question. Compute each of the following. The first question, we can expand it by using the distributive law, right? So 1 by -9 is -9, and then 1 by 2i is 2i. Then -5i times -9 is plus 45i. Then -5i times 2i is 10i squared. And then we can simplify. -9 minus 10i squared. I squared is -1, then times -10 is plus 10. Then plus 47i, right? And the final result is 1 plus 47i. Okay, next one. Again, we can expand it using the distributive laws. 4 by 2 is 8, and 4 by 3i is 12i. Then I by 2 is 2i, and I by 3i is 3i squared. Okay, then we can combine the real part, which is 8 minus 3, right? Then combine the imaginary part, which is 14i. So the final result is 5 plus 14i. Okay, please have a look at this and let me know if you have any questions. Okay, question 3. Actually, this is the third time we have done this question, right? So please pay attention this time. I hope you can do it correctly next time. If you want to compute the sum of a series like this is actually a geometric series, right? Geometric series, which means the ratio between the two adjacent terms are equal, right? So usually we'll denote it with a letter S. For example, you can let S equal to the original expression, which is 1 plus I squared. then I to the power of 2020, and then I to the power of 2021, right? Okay, so if S equals this expression, then we can time the common ratio. This is called the common ratio, which means the ratio between the second term to the first term, or the third term to the second term. So as you can see here, I over 1 equals I squared over I equals I third to I squared, etc. equals I 2021 over I 2020, right? So I is the common ratio. So usually we'll multiply an I to both sides. That means IS equals I plus I squared, and then plus I to the power of 3, and then I to the power of 2021, then I to the power of 2022, right? Can you follow me? Okay, then we label the first expression with 1 and second with 2. And then what's the next step? In the next step, we can cancel some of the terms if we use 1 minus 2, right? So expression 1 minus expression 2 will give us left side is S minus IS, and right side is 1 plus I squared plus I 2020 plus I to the power of 2021, then subtracted by I plus I squared plus I cubed, etc. to I 2021 and I 2022, right? Then you can see that this is actually, first of all, left side, S is a common factor which can be put in front, and what's left behind is 1 minus I, right? And then we'll process the right side, which we can cancel I squared, I cubed, etc. until I 2020 and I 2021, right? With the terms in the later part, right? So what's left is I is also canceled. So what is the result in the right side? Can you tell me? If you cancel all these terms, okay, so right side is 1 minus, right? Minus I to the power of 2022. So our target is to find S, right? So note S is the sum of all the terms. So our target is to find S. Okay, remember that our target is to find S. So that means from here, we can divide both sides using I minus 1, right? So S is 1 minus I to the power of 2022 over 1 minus I, right? But it's not over yet. We need to simplify. Actually, I to the power of 2022 can be simplified. So I to the power of 2022 is actually I squared to the power of 1011, right? And then divided by I, 1 minus I. So I squared is minus 1. So the numerator is I minus 1 to the power of 10, 11. Then over 1 minus I, right? Which means minus 1 to a even power is minus 1. So 1 plus 1 over 1 minus I, right? And it's still not over yet. Remember that we need to simplify the result to a form of A plus BI, right? This is our target. So we have 2 times 1 plus I over 1 minus I times 1 plus I. We need to rationalize the denominator. So this gives us 2 times 1 plus I, then 1 minus I squared, right? And 1 minus I squared is actually 2. So the final result is 1 plus I. Can you follow me? Okay, so please have a look at the solutions. Next time I hope you can solve it by yourself, okay? Well, actually, let me give you another example. So for example, if we have a geometric series such as 2 plus 4 plus 8 plus etc. to 2 raised to the power of 10 and then to the power of 11. So how do you compute this? This is actually 2 raised to the power of 1, then to the power of 2, and then to the power of 3, right? So basically the method is similar, right? We can use a letter S to denote. First of all, you need to recognize this is a geometric series because the ratio between the second term to the first term is 2, right? And the third term to the second term is also 2. So when you have a common ratio, this series is called geometric series. Understand? So when you want to find the sum of a geometric series, you can use similar method. You can use the letter S to denote all the terms behind. The sum of all the terms. And then in order to find S is the number you want, right? In order to find S, you can multiply both sides using the common ratio, which is 2, right? So if you let S equals the sum of all the terms, then 2S equals what? 2 to the power of 2, then 2 to the power of 3. Then, sorry, this should be 2, not 3. Then 2 to the power of 4, right? And then all the way to the last term, 2 to the power of 11, and then 2 to the power of 12, right? And let's call this 1, and this one is 2. Then you can use 1 minus 2, which will give you S minus 2S equals minus 2 to the power of 2, 2 to the power of 3, all the way to 2 to the power of 10, and 2 to the power of 11, and then 2 to the power of 12, right? And the left side, as you can see here, is s times 1 minus 2, right? And right side, similarly, we can cancel 2 to the power of 2, 2 to the power of 3, etc., 2 to the power of 10, and 2 to the power of 11, right? All these terms in the middle are canceled with the terms in the later part. And the right side is just 2 to the power of 1 minus 2 to the power of 12, right? Can you follow me? Okay, so this means 1 minus 2 is minus 1. S equals 2 minus 2 to the power of 12, right? So that means S is 2 minus 2 to the power of 12 over minus 1, right? And then you can calculate 2 to the power of 12 using calculator. So instead of calculating each term separately in the original expression, this time you can just calculate 2 to the power of 12 once, right? So it will save you some time. Understand? This is a shortcut to calculate the sum of a geometric series. So be careful with this, okay? So next time, once you want to calculate the sum of a geometric series, you can consider using this method, right? Actually, there is a formula which can be obtained using this method. Probably you'll be learning this in your mathematics in your school thing. So by the time you learn the formula, I'll explain the formula for you, okay? So currently, just remember that if you want to calculate a geometric series, you can consider using this method, okay? All right, so let's have a look at the next one. Question 4. If A is a real number and the product of 2A plus 5I and 4 minus 7I is a real number, find the value of A. Okay, so a product of two complex number is still a complex number, right? So if a complex number, for example, m plus ni is a real number, that means the imaginary part is 0, right? So first of all, let's expand this complex number. This is actually eight a minus 14ai plus 20i minus 35i squared, which is 8a plus 35. This is the real part, right? And then plus 20 minus 14ai. This is the imaginary part. So as I said, if this complex number is a real number, then the imaginary part must be 0. So that means 20 minus 14a is 0, right? So this gives us a is 20 over 14, which is 10 over 7. This is our result. Okay, a is 10 over 7. Okay, next one, express each of the following as a standard form complex number. Standard form complex number has form a plus bi, right? So our target is to convert each of the expressions into a complex number with this form. Usually we'll need to rationalize the denominator, right? By multiply the denominator using its conjugate complex number, right? So first of all, for the first question, we can multiply both the numerator and denominator using 2 minus 7i, right? Because 2 minus 7i is conjugate number of 2 plus 7i. And this will give us expand the numerator, which is 6 minus 23i plus 7i squared, right? And the denominator is 4 minus 49i squared, right? And denominator, numerator now is minus 1 minus 23i, and denominator is 53. So the final result is minus 1 over 53 minus 23 over 53i. Okay, this is in the form of a plus bi. Okay, second question, we can just multiply both the numerator and denominator using an I, right? So if you multiply it with an I, 2i times an I will give you a real number, right? So this is 6i minus 9i squared over minus 2, right? Okay, so this is 9i squared is 9, then plus 6i over minus 2. This will give us minus 9 over 2 minus 3i, right? Which is also in the form of a plus bi. Okay, any questions? If not, let's have a look at question 6. Okay, question 6. The number 12 plus I can be factored into the product of 2 plus 3i. And what other complex number? So first of all, we can express 12 plus I to the product of 2 plus 3i with another complex number. If you don't know the other complex number, you can express it as a plus bi, right? And then as long as we find the values of a and b, we can solve the other complex number. So note here, a and b are both real numbers, right? Okay, so this is equivalent to left side, you can just keep that. Right side, we can expand it, right? So right side is 2a plus 2bi plus 3ai plus 3b squared, right? Which is equivalent to 12 plus I equals, we can combine the real part, which is 2a minus 3b. Then combine the imaginary part, which is 3a plus 2bi. Okay, so when you have the complex number on the left side equals the complex number on the right side, that means their real part should be the same, which is 12 equals 2a minus 3b, right? And also their imaginary part are also equal. So 1 equals 3a plus 2b, right? So that means you successfully can convert the original problem into a system of 2 linear equations. So now we need to solve this system of linear equations, right? Which we have already learned how to do it. So this gives us, first of all, the first equation we can multiply both sides using a 2, right? So this will give us 24 equals 4a minus 6b, Then the second equation, we can multiply both sides using a 3. So 3 equals 9a plus 6b, right? And we can add the two equations, which will give us 27 equals 13a, right? So that means a is 27 over 13. Then we can put a equals 27 over 13 back to either equation to find b, right? So b is 1 minus 3a over 2, according to the second equation, which seems simpler, right? b is 1 minus 3a over 2, which is 1 minus 3 times 27 over 13 over 2, which is 13 minus 81 over 13, then over 2, which is minus 68 over 26, which is minus 34 over 13, right? And therefore, the solution is a equals 27 over 13, b is minus 34 over 13. And the other complex number is, of course, 27 over 13 minus 34 over 13i, right? Okay, so please have a look at the solution and let me know if you have any questions. Okay, good, you understand. So I hope next time you can do it correctly by yourself, okay? All right, so now let's have a look at question 7. Question 7 states that if we know that a is 3 plus 2i squared over 2 plus I, find a minus the reciprocal of a in a standard complex number form. Okay, standard complex number form is a plus bi, right? So we need to find the result of a minus the reciprocal of a 1 minus the reciprocal of a in the form of a plus bi, right? So usually there is no shortcut, so we can just calculate this expression step by step. So first of all, 1 minus the reciprocal of a is, we can just plug a into this expression, right? Which is a 1 minus 2 plus I over 3 plus 2i squared, right? And then we can write it using a common denominator, which is 3 plus 2i squared over 3 plus 2i squared minus 2 plus I over 3 plus 2i squared. Okay, and then we can combine the numerator, which is 3 plus 2i squared minus 2 minus I. So pay attention to the minus symbol here, right? This is not a plus, but a negative symbol here. Usually, it's very easy to make mistakes here. Over the common denominator, which is 3 plus 2i squared. Okay, so now we can expand the numerator, which is 9 plus 12i plus 4i squared minus 2, then minus I, right? Over expand the denominator, which will give us 9 plus 12I plus 4I squared, right? Okay, so the numerator is 9. Okay, let's consider the real part. 9 is a real number, 4I squared is a real number, and then minus 2 is also a real number. So if we combine these three numbers, this is 9 minus 4 minus 2, right? This is a real part. And the imaginary part is plus 12 minus 1I. And for the denominator, 4I squared is a real number and 9 is a real number. So the real part is 9 minus 4, then plus 12I, right? The next step, the numerator becomes 3 plus 11I, and the denominator is 5 plus 12I, right? So this seems a little easier. In the next step, we need to rationalize the denominator by multiplying its conjugate number, right? So the conjugate number of 5 plus 12I is 5 minus 12I, right? So we need to times this number to both the numerator and denominator. So 3 plus 11I times 5 minus 12I, then over 5 plus 12I times the conjugate number 5 minus 12I, right? Okay, then we need to expand the numerator and denominator respectively. For the numerator, we have 15 minus 36I, then plus 55I, then minus 12 by 11 is 132, then I squared, right? Sorry, not 132, 13. Check. Oh yes, 132 I square and over, okay, the denominator, according to the formula, we have 5 squared minus 12I squared, right? Which is 25 minus 12I squared. And the numerator is 15 plus 132. This is a real part. And the imaginary part is plus 19I, right? And the denominator is 25 plus 144, okay, which is 147 plus 19I over 169, right? And in a standard complex number form, this is 147 over 169 plus 19 over 169I. Okay, please have a look at the solution and let me know if you have any questions. Okay, I was looking at your solutions. I think next time you need to pay attention when you use this formula. Okay, something like m plus n squared. When you use this formula, this is not m squared plus n squared, but m squared plus 2mn plus n squared. You forget the term in the middle, right? Okay, so next time, please be careful with formula. And the other one is actually m squared minus n squared, right? The other one states that m squared minus n squared is m plus n times m minus n. So be careful with these two formulas. If you cannot use them correctly, you will get the wrong result. Okay? Okay, my suggestion is if you can't remember them correctly, it's better for you to have a cheat sheet and stick that to your desk, and you can refer to them at any time. That will help you memorizing it. Okay. All right, next one. Question 8. Okay, so this time we are given the value of x, which is actually a complex number, and then find the reciprocal of x squared minus x in a standard complex number form. Okay, so this time actually there is not a obvious shortcut, so we'll just calculate the expression step by step. So the expression states that 1 over x squared minus x, right? So I think instead of calculating x squared minus x, we can calculate the product of x times x minus 1. This will make the calculation a little bit easier. So this is 1 over x. You can just copy x into this expression, and then x minus 1, right? And then we can calculate this one first. Okay, so 1 minus I times square root of 2 over 3. Then the later part is 1 minus I times square root of 2 minus 3 over 3, right? Which is 1 over 1 minus I times square root of 2 over 3 times minus 2 minus I square root of 2 over 3, right? Okay, so we can multiply both the numerator and denominator using a 9, right? This will cancel the denominator here, which will give us 1 minus I times square root of 2 times minus 2 minus I times square root of 2. And this is, then we can expand the denominator, right? Which will give us minus 2, then minus I times square root of 2, and then plus 2I times square root of 2, and then plus I square times 2, right? Okay, so let's simplify the denominator now. First, let's consider the real part. This is a real number. This is also a real number. So let's combine them. Minus 2, then minus 2 is minus 4. Then 2i times square root of 2 minus I times square root of 2 give us I times square root of 2, right? Okay, so this expression now seems a little easier. Now we need to rationalize the denominator, which we need to multiply both numerator and denominator using the conjugate number of the denominator, which is minus 4 minus I times square root of 2, right? And this will give us minus 36 minus 9i square root of 2, and denominator is 16 plus 4i square root of 2 minus 4i square root of 2, then minus I squared times 2, which is minus 36 plus, minus 9i square root of 2 over 16 plus 2, which is minus 36 minus 9i square root of 2 over 18, right? And in the form of a plus bi, this is minus 2 minus square root of 2 over 2 times I, right? So the final result is this number. Okay, so have a look at the solution, and if you have any questions, let me know, okay? Usually there is no better way to calculate this. Just be careful with the calculation in each step, and you will get the correct final answer. Okay, any questions? No? Okay. Last question. Find all complex numbers a plus bi, where a and b are real numbers, such that the conjugate of a plus bi equals b plus ai squared. Okay, so let's start from the given information here. A plus bi conjugate equals b plus ai squared. This is actually equivalent to the conjugate of a plus bi is a minus bi, right? And the right side, we can just expand it, which means b squared plus 2abi plus ai squared is the right side, right? And this is equivalent to right side is a minus bi, left side is a minus bi, and right side is b squared minus a squared. This is a real part, and the imaginary part is 2abi, right? And as you can see here, you have two equal complex numbers. If two complex numbers are equal, that means the real part should equal the real part, and the imaginary part should equal the imaginary part, right? So this is equivalent to, first of all, real part of the left number is a, equals the real part of the right, which is b squared minus a squared, right? And the imaginary part of the left is minus b, which should equal the imaginary part on the right, which is 2ab, right? You follow me? Okay, so that means we have again a system of two equations, right? So let's try to solve this system of equations. So first equation gives us a squared plus a minus b squared is 0. Second equation states that b plus 2ab should be 0, right? And this is equivalent to, first, just keep this first equation unchanged. And we can start from the second equation because it seems a little easier, right? B is common factor, so let's put it in front. So what's left behind is 1 plus 2a, right? Okay, so this is equivalent to, the second equation is equivalent to b is 0 or 1 plus 2a is 0, right? And let's just keep the first one unchanged. So let's call this number 1 and number 2. Okay, system number 1 is equivalent to, first, if b is 0, then the first equation in system 1 means a squared plus a is 0, right? Which is equivalent to b is 0 and then a times a plus 1 is 0, which is equivalent to, first, b is 0, second, a is 0, right? Or when b is 0, a can also be minus 1, right? So these are possible solutions for A and B in the first system. And in the second system, number 2, this is equivalent to, first, A is minus 1 over 2, right? And second, we can just put A equals minus 1 over 2 to the first branch, which is 1/4 minus 1/2 minus b squared is 0, right? And this is equivalent to a is minus 1/2 and b squared is minus 1/4, right? You understand? Can you follow me? Okay, so note here, a and b are real numbers, right? For a real number, b squared is minus 1/4. That means there are no solutions for such b, right? Because a real number raised to the power of 2 always give you a positive number. It cannot be negative 1/4, right? So this means in this case, there is no solution to b. That means b belongs to the empty set. When a is minus 1/2, right? So the only possible solutions are here. Okay, and now we can make the conclusion. The possible complex numbers are either when a is 0, b is 0, the number is 0, right? Because 0 plus 0i is 0. Or minus 1 plus 0i, which is minus 1, right? So the only possible complex numbers are 0 or minus 1. Do you get it? So get yourself familiar with this method, and I hope you can solve it independently next time, okay? So based on your performance of this assignment, I think we'd better practice this again. Okay, once the new assignment is ready, I'll let you know. Okay, probably you need to wait for 2 or 3 days. Okay, I'll upload my notes here to Google Classroom. You can download it as a reference. Okay, please do correct your solutions after the class. Okay. All right, so if you don't have any questions, you're free to leave. Have a nice day.